Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video, guys, I'll be tackling the fourth question, whereby I'm only focusing on chemical equilibrium. Please do expect a total number of 8 videos, since I've compiled a worksheet that has 8 questions in total, and all of these questions, guys, are all extracted from past exam question papers. So please, guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your final examination. So please do share the video to your peers so that they may have the same edge as you. And please, guys, do help us grow the channel by just subscribing. Okay, hydrogen and iodine are sealed in a 2 cubic decimeter container. The reaction is allowed to reach equilibrium at 700 degrees at 700 kelvins rather, according to the following balanced equation. We do have hydrogen and iodine, and we will form hydrogen iodide. Firstly, they want us to give a reason why changes in pressure will have no effect in the equilibrium position. Okay, please remember that, guys, if ever you increase pressure, you will favor the side with the least number of gases. But if you decrease pressure, you will favor the side with the most number of gases. Now, on my left hand side, guys, I have 2 gases. For me to count gases, guys, I must consider the stoichiometric coefficients, right? So this is just 2. On the other side, I have 2 altogether. So the number of gases, they're both balanced, guys, in the left hand side and the right hand side. Né? So there's no side that is going to be favored if ever you increase or decrease pressure. Are you together? But what will happen if you increase pressure? You just increase the rates of both reactions, of the reverse and the forward reaction. If you decrease pressure, you will decrease the rates of reaction for both pressure. Rather, will decrease both the rates of reaction for both forward and the reverse reaction. Né? So the pressure will have no effect on the equilibrium position. Okay, 6.2, we are told that at equilibrium 0.028 moles of hydrogen and 0.017 moles of iodine are present in the container. They want us to calculate the initial mass of iodine in grams, and then calculate the initial mass of iodine that was sealed in the container if the Kc for the reaction is 55.3 at 700 kelvins. Okay. For my Kc, guys, ne? No, this is too much. It's too large. For my Kc, okay, I'll have initial moles, the change in moles. This will be the moles at equilibrium, and this will be the equilibrium concentration. That's N over V. Né? I was only given the number of moles, guys, at equilibrium. Né? I was told I have 0.028 over here, 0.017 over there. I have hydrogen, I have iodine, and I have hydrogen iodide. Okay, let's say we have used X number of moles over here, guys. Né? Since the ratio is 1:1, that means we have also used X number of moles over there, and this simply means we have produced 2X number of moles. Why am I saying it's 2X? Because the ratio is just 1:2. Are you together? That means I'll only use 1 mole of this to produce twice the amount. Are you together? So since I've used X, that means I'll produce 2X. Okay, now, guys, let's go and find our initial moles. Initial moles, guys, will simply be the number of moles that were used. The number of moles that were used plus the moles at equilibrium. Same thing applies with iodine. The number of moles that were used plus the number of moles at equilibrium. Are you together? But remember that when the reaction began, we did not have hydrogen iodide. Are you together, guys? So since, guys, we do not have hydrogen iodide, that means we are going to add from the on the product side. We had 0, and then we added 2x. That means at equilibrium we'll simply have 2x as well. We simply have 2x as well. Now, okay, now we must simply calculate the volume. Now, how can we find the volume? We can simply find the volume, guys, by dividing the number of moles. Rather, we can find the concentration, the concentration by dividing the number of moles with our volume. Now, our volume is 2 cubic decimeters. Let me confirm. Yeah, our volume is 2 cubic decimeters. That means I have 0.028 divided by 2. And then this will just give me 0.014. 0.017 divided by 2. That's just 0.0085. And then the concentration over there will simply be equal to x. It's good. So I now know that I can simply say Kc is equal to the concentration of my products raised to their stoichiometric coefficients divided by the concentration of my reactants. The concentration of my reactants. The Kc value it was given to us as 55.3. Let me confirm, guys. Yeah, the Kc is 55.3, right? And then the concentration of hydrogen iodide is just x, but this thing is squared. Then I simply have the concentration of my hydrogen 0.014, concentration of iodine 0.085. That means x squared is basically equal to 55.3. I'm cross multiplying. Multiplied by 0.014 multiplied by 0.0085. Just take the square root on both sides. The square root on both sides. Then x is basically equal to the square root of 55.3 multiplied by 0.014 multiplied by 0.0085. So this will just give me 0.0811215137.9. So x, guys, is basically 0.0811215137.39. Yeah? This is the number of moles that were used, guys, remember, for both hydrogen and iodine. So I can simply calculate the initial number of moles for my iodine. So therefore, the number of moles for my iodine initially, this is basically the answer which I got, which is 0.0811251379 plus the number of moles I had at equilibrium. That's just 0.017. And this will simply give me an answer of 0.098 moles. Yeah, 0.09, or let me round off to 4 decimal, guys. 0.0981 moles. So these are the initial number of moles, but I was never asked to find the initial number of moles of iodine, but I was asked to find the initial number of moles, rather I was asked to find the initial mass of iodine. I know that number of moles is equal to mass all over the relative atomic mass number. Or rather, let's just not round off, guys. We'll round off at the end. 1, 2, 1, 5, 1, 3, 7, 9. Yeah. We are looking for the mass. I know that mass will simply be number of moles multiplied by the relative atomic mass number. That's just 0.098125137.9 multiplied by iodine has a molar mass of 127, but I have 2 of them. Remember that it's written as I2. I have 2 of them, that's why I need to multiply it by 2. So I'll simply take the number of moles multiplied by 127 times 2. This will simply give me a mass of 24.92 grams. 24.92 grams. So initially, guys, I had 24.92 grams of iodine. 24.92 grams of iodine. Yeah? Okay. And then we are told that the reaction rate versus time graph below represents the different changes made to the equilibrium mixture. Okay. Over here, guys, once you see a parallel line there, please note that the reaction is at equilibrium. So the reaction is at equilibrium over there, over there, over there, and over there. Our reaction is at a state of dynamic equilibrium. Yeah? But you can see changes that happens there. There's another change that will take place there. Another change will take place there. Yeah? Okay. What do the parallel lines in the first 2 minutes indicate? They indicate a state of dynamic equilibrium or a state of chemical equilibrium. Yeah? Okay, then 6.4. We must state two possible changes that could be made to the reaction condition at 2 minutes. We can only see such a change that happens over here, guys, if and only if a catalyst was added. If a catalyst is added, guys, there's no side which is going to be favored. Yeah? You are not going to favor either the forward reaction or you are not going to favor the reverse reaction. Just note that you will increase the reaction of both the reverse and the forward reaction. Are you together? And secondly, what else could have happened? We could have increased the pressure. By increasing the pressure, guys, you're just increasing the rate of both the forward and the reverse reaction. Why? Because pressure has no effect. Remember the first question, guys, né? Pressure has no effect since you have equal number of gases on the left hand side and also on the right hand side. So the two possible changes that could have happened when time is equal to 2 minutes, you could have only added a catalyst or increased the pressure. Okay, and then now for 6.5, you are told that the temperature of the equilibrium mixture was changed at t is equal to 4 minutes. Since there was a change in temperature, guys, it's simple, and I can see that the rate of the reaction decreased. That means my temperature was decreased. Number one. Are you together? And with the decrease in temperature, I can see that the reverse reaction was favored. Okay, yeah, the reverse reaction was favored. Né? How do I know that the reverse reaction is favored? Please check that. If, guys, I favor my reverse reaction, it simply means I'm going to use my products to form reactants. Are you together? I'm going to decrease the concentration of products and increase the concentration of reactants. Né? Over here, the dotted line shows the reverse reaction. So over here, guys, I can see that, okay, the reverse reaction, after the change only happens at 4 minutes. Né? But after the change has happened, I can see that my reverse reaction is favored because it decreases. Are you together? It decreases and the forward reaction increases over there. So since my reverse reaction, guys, is favored at a lower temperature, I can conclude that the reverse reaction is exothermic and the forward reaction is endothermic. Now, guys, the explanation would be a decrease in temperature will always favor an endothermic reaction, and in this case, since the reverse reaction is favored, I can therefore conclude that the reverse reaction is exothermic. Are you together? Okay. And then now we are being asked, how will the change influence the Kc value? Choose from increase, decrease, or remain the same. Since guys the fourth reaction is endothermic, ne? If we decrease temperature in an endothermic reaction, please note that our Kc value will also decrease. If you decrease temperature in an endothermic reaction, the Kc value will also decrease. Then now we are being asked, what change was made to the equilibrium mixture at t is equal to 8 minutes? I can see that the rate of the forward reaction decreased, and it's only the rate of the forward reaction. Né? So that, guys, simply means that one of my reactants was removed. Either hydrogen was removed or iodine was removed inside the reaction vessel. That's how, guys, we're supposed to tackle that question. Né? But I think I made a blunder there, guys. Né? Oh yeah, let me re-explain. I chose endothermic reaction, guys, which is a correct answer. Why? Because a decrease in temperature always favors an exothermic reaction. This graph shows me that the reverse reaction is exothermic. This graph shows me that the reverse reaction is favored. Are you together? And since a decrease in temperature favors an exothermic reaction, it simply means the reverse reaction is exothermic, and hence the forward reaction will be endothermic. That's how, guys, that's how you're supposed to fully explain your answer. So please do stay tuned, guys, and wait for more videos. Thank you for your time.